Hey folks, Matthew Lanigan here with BayWa RE. We're just going to give it another moment. Still see people signing in. We'll be back with you here in just a minute. Thanks so much. Hey folks, Matthew Lanigan here again with BayWa RE. I'm the Chief Commercial Officer here at BayWa. Just wanted to thank you all for taking time out of your busy day to be with us and IMO to learn a little bit more about their product. A couple of housekeeping notes. This will be recorded. We will be sharing it on our YouTube channel. If you haven't already, please sign up for that. You can find all our past webinars on there as well. And it'll also be shared in the monthly newsletter. You'll notice you can write questions in the bottom right-hand corner here on your screen. There will be breaks for questions, so we'll take, please put them in as you have them, but we'll answer them during the breaks. Continuing education is really big for BayWa. We like to do it internally and are happy to be able to share it with our customers as well. So I just want to check real quick if we could just do a test, if somebody could put their name or say hi in the chat box. Just want to make sure things are working there. Okay, great. And without further ado, I would like to introduce Jason Hanna, Field Sales Engineer with IMO. Jason.
Oh, thank you, Matthew. I'm going to switch the screen over. Okay. Matthew, is the slide coming up, the first slide?
Yes, we can see it.
Okay, perfect, perfect. Okay, well, thank you very much, everyone. As Matthew mentioned, my name is Jason Hanna. I'm the Field Sales and Technical Engineer at IMO Precision Controls. Today's presentation is going to be on our DC disconnects and our AC disconnects, starting with our DC disconnects, where they're needed and how they're sized. This seems to be a strong product for us in both solar and a lot of other renewable energy storage systems and so on. So the agenda today is one that will start off with just a generalization of our product line. It's just a single slide, just describes all the products that can be applicable to a solar installation. We'll quickly get into applications where disconnects are used, followed by sizing of DC disconnects, showing two examples. Then right into the product overview and features, and also showing the switching difference. What makes our disconnect different from everyone else's? We'll get into a small briefing on disconnect comparisons to other competitor lines out there. We'll have a brief question part for the DC disconnects, where then I can go into the AC disconnect for a quick presentation on that. So first of all, the IMO solar products consist of three main lines. We have the Fire Raptor, which is our rapid shutdown module have a rapid shutdown system for PV panels. We have our AC disconnects and our DC disconnects. The applications typically used for the DC disconnects, we start with a common DC disconnect for ground mounted systems. Now you'll notice that it'll mention a lot about the code. This presentation was originally designed around the NEC requirements. So I've taken a lot of that code written out, but a lot of the things are relevant to systems here in Canada. As we always say to everyone else, illustrations of these installations are for references only. Installation and code compliance may be different in your area, so we advise always to check with your local electrical authority for any type of information. Anyway, with the disconnect for ground-mounted systems, we have a disconnector shown here locally installed near the PV array. Under the certain codes, it has to be considered an enclosed disconnect or an equipment disconnect. An equipment disconnect essentially means it's able to break the load, break under load, and at the same time isolate. Our disconnects are perfect for that, in that they're an enclosed NEMA 4X enclosure. It's not easily you can't get in it without tools, so it protects the operator from energized parts. Generally, these are installed 3 meters or 10 feet from the array as a convenience. Also, too, another mandate of switching disconnects has to be that the operator has to have a clear indication whether the circuit is on in the closed position or off in the open position, and it needs to be lockable in the off position. Again, like I mentioned, these disconnects we have serve two purposes as a disconnect and isolator as well, too. For ground-mounted systems that are combined, we seem to have a really good high amperage, high voltage enclosed disconnect for this. In this case, because we're combining the voltages and amperages, we end up with a higher voltage, higher amperage, which is perfect for our disconnects, as it is an equipment disconnect, so it'll break under load. But as well, it provides an isolation to circuits downstream of the disconnect, so inverters, charge controllers, or what have you. Again, it has the same visible markings of an open or off position or on position closed, and it is lockable in the off position. Interesting enough, we have disconnects rated higher than 30 amps. We have a standard size that's up to 30 amps. Now we have ones that are up to 65 amps and up to 1,000 volts DC as well, too. So it's perfect for these types of ground-mounted systems. An example that we come across, again, this is a lot more predominantly in the States, I think. There's a little bit of it up here, but predominantly we've been getting a lot more into the vehicle charging systems for home uses. And essentially, they have a battery energy storage system located outside near an inverter or charge control system, and that's attached to the panel inside. For the safety of emergency workers or just the convenience of working on the system, the disconnect is located outside, usually near the beater base, somewhere visible, highly visible, and easy to shut down. So it provides the means of disconnecting power under load, as well as isolation, so we'll isolate the systems altogether. And also it's usually in line of sight of the energy storage system as well, too. We've actually allianced with a company called Generac for their power cell systems. We're actually one of their disconnect recommendations, and the reason behind that is they have energy systems that are generally located inside the house and generally connected to a PV array outside. So the disconnect actually acts as not only a means of isolation and disconnection, but because they use power line communications up to the PV array, it also serves as an ideal initiation circuit for the rapid shutdown. So it has all the check boxes for, the visible on and off of status of the disconnect, the NEMA 4X rating for the outdoors, and as well too, it serves as that rapid shutdown initiator. Generally in more common systems like a DC coupled multi-mode system, we'll find our disconnects in two places. Our DC disconnects can be found isolating and disconnecting from the PV arrays as well as the energy storage systems. And basically its main purpose is to isolate that inverter in multi-mode. The AC disconnects are generally the means to disconnect those multi-mode inverters to the panels themselves, providing a clear disconnection from the panel. The same can be said with the AC coupled systems. In this case, we're just adding another AC disconnect between the inverter that's coming from the energy storage systems to the panel as well. And in this case, the AC coming out of the first inverter multi-mode going to the backup panel, and the backup panel going to the second inverter system. So there's two coordinating AC disconnects used to disconnect and isolate both the PV arrays, the battery energy storage system, as well as utility power as well too. So how to size the DC disconnect? We're going to use two examples, just two common examples here. We're going to have a standard ground mounted array with multiple circuits going into an inverter. And the second one will be more of a combined or high current event where we have multiple strings being brought into one and having a higher voltage and current disconnection. One of the tools you'll need is our solar products catalog. This contains all the technical information about the disconnects as well as the ampacity and all the specification. We have a hard copy, but we also have a PDF copy available for download as well. From that, I'm going to be citing a few pages out of it. Because the catalog is used for other countries, it's a worldwide catalog, the applicable pages that have to do with North America, Canada, and US are found pretty much on 4 pages. So the first page I would direct you to is page 20. And you'll see in the right-hand side of the pane, you'll see a variety of different configurations, voltages, and amperages. Now, we do have 2 series of disconnects. We have the SI16 to SI38, you'll see on the top. You'll see the amperages are good up to and including 600 volts DC. And then we continue that with our SI40 to SI65, which allows for amperages up to 1,000 volts DC. And these are both UL and CUL approved. So what we do is we start out with a disconnect switching one string. Now, in order for us to obtain the higher amperage of switching, we switch both the positive and negative. So essentially, when you're switching a positive and negative, that's a circuit that's in series. So usually we start the conversation out with the middle section where you see 2 poles in series. We don't normally use the 1 pole because we're not disconnecting the negative. So you can see the amperages go considerably down. So we start our conversation with 2 poles in series. That would be considered 1 string. And all we do is if we want to increase the amperage, we just start adding poles. The offset of that, of course, is as we're increasing the number of poles, we use up more disconnect space. So after that, after you figure out which amperage and voltage combination you have that's applicable to your application, we then go to our page 14, which is actually our wiring diagram for these disconnects. So as I mentioned, we start with a 2-pole, which is your positive, negative being switched to your load. But it also illustrates other disconnects. We have 4 poles, we have 6 poles, and we have 8 poles. And you can see that depending on the jumper combination, we can switch either up to 4 separate strings at once, or if it's a very, very high ampacity, like 70 amps at 1,000 volts DC, then we can get into a single disconnect with multiple jumpers and 1 load. So that would be considered 1 string disconnection. And then lastly, page 13 in the catalog, it gives you the variety of different mounting types. The most common that we're finding in North America, obviously, is the enclosed type. You'll see a lot of our other open frame type disconnects in several inverter manufacturers, as we've been chosen as one of the most convenient lines to go into smaller spaces, which I'll explain the reason in the product overview. And of course, with that, you can design your part number around that. So we start with the nomenclature of the DC disconnect, which is SI. we start with the base amperage of 16, 25, 32, 38, 40, all the way up to 65 amp. These are base amperages, what we call, that's basically 600 volts at 65 amp down to 16 amp. Of course, as we add jumpers and so on, the amperage increases, and that's what that page 20 illustrates, is that you can actually have higher ampacity switching depending on the disconnect and jumper combination. I think this will be more clear as we get into a example. So I picked out a solar module here, and the only information we require off the module is the PV panel's VOC voltage and the ISC amperage, as well as the number of strings as well too. And it's also good too to know what kind of mounting you'd like as well. Like I said, we get more calls for the enclosed styles than the open styles. So our first example is a 2 arrays, just a simple ground mount array going into a house. We have 2 strings. Each panel in the array are 9 panels. We saw from the example that the VOC is 47.7 volts DC. The ISC is 11.51 amps. So the calculation for the first string, we take our total voltage, so that's 47.7 volts DC times the 9 panels. We get 429.3 volts DC. The amperage remains at 11.51. Now you'll notice an NEC adjustment amperage. I don't know if that's applicable in certain places, but it's in the States. You have to add a 1.25 or a multiply 1.25 adder to round it up to, in this case, 14.39 amps. So that's per string. So per array, we've sized it for 429.3 volts at 14.39 amps. Same thing in array number 2. We then go into that page 20 we were mentioning. And in this case, I'm going to start the conversation with the 2 poles in series. So we know that we have 429.3 volts DC with 14.39 amps per string. So from that, we look at the sheet and we find that the closest is the SI16, which is 500 volts at 16 amps, and that's 2 poles in series. So there's no jumpers on that disconnect. It's strictly the positive and negative that are being switched. So from that, there's a little number underneath. It says 2. You'll see others. There's 1, there's 2H, there's 4S, and so on. That's the configuration of the disconnect. So that we keep in mind the configuration number 2, and the disconnect series that we've chosen is SI16. We then go back to page 14, which is our configuration, our wiring configuration, and you'll see that we have the -2 as a single string or 2-pole environment. And with that, we now can go to a 4-string because we have, or sorry, a 4-pole because we have 2 strings. So we take the number of 4 now. Instead of 2, we take 4. We then go into our part number configuration. We know that the disconnect series was an SI16. We jump down to the configurator, which shows the variety of different open and closed styles. The most common is the PEL64R. That's the enclosed with a lockable handle, NEMA 4X enclosure. And then we just add the -4, which was the configuration tool. For something with a larger voltage, for example, we have a few arrays in parallel and then back into series. We start with those panels. Each of them are 47.7 volts DC with an ISC of 11.51. So each array is going to consume 18 panels in series, 47.7 volts DC. That brings us up to 858.6 volts DC and the amperage at 11.51. We then combine 4 sets. The voltage remains at 858.6 volts DC at 11.51 amps. Multiply that by 4. We have our amperage now up at 46.04 amps. Again, we apply that 1.25 adjustment if applicable, and it brings it up to 57.55 amps. We go back into the configurator, and with that in mind, we only need a single string this time because we're just isolating after the combiner. We find that we have one that has 4 poles in series that will accommodate up to 1,000 volts DC and 65 amps. We then go into our configuration and we see that we have a variety of different styles. Now that 4-pole with jumpers is available in 3 different configurations. This is where the jumpers are mounted. So if you can visualize the disconnect in this case, you'll have your lines coming in the top and the load coming out through the bottom. The next one beside it is line and load coming strictly from the bottom. This one's probably more popular, then you're not drilling holes and putting special grommets and so on the top of the...
Jason?
Yes.
Sorry, Jason, sorry to interrupt. Is there a way to make your screen larger so folks can see it a bit better? Is there a way to hide the next side there?
Let's have a look here. Yeah, there's no option on PowerPoint for enlargements of screens. I apologize.
It's okay.
Let's double check here. Yeah, is it hard to see the graphics? Okay.
A little bit, yeah.
Oh, okay. Yeah, unfortunately, there's no option on here to enlarge the screen.
Okay.
I apologize. I can send I can send this presentation out in PDF form.
Sure, that'd be great, and we can send it out folks after. Perfect.
Apologies. Yeah. Okay. Yeah. Okay. So basically, as I mentioned, the 4-pole has 3 different mounting options, and this is just where the lines are coming into the disconnect, and this is just depending on how you're going to mount it. And again, we get into the part number configuration utility. We start with the SI65, which we found, which was covering the 1,000 volts DC at 65 amps. Continue on with the part number of PEL64R, which is our enclosed NEMA 4X disconnect. And then 4T. I've chosen 4T only because, as I mentioned before, I know it's probably hard to see, in the 4T style, both line and load are being wired through the bottom of the disconnect. Again, very, very common. And that would be your final part number. Now, I'm saying that if anybody has any configuration questions, they can definitely contact our team at BayWa directly, or give us an email, and then we can put a part number together for you as well too. Just a little bit of comparisons. The common disconnects we keep stock in North America are basically 2 different sizes. We have our SI32 PEL64R-4, and then we have the -6 and the -8. Now the -6 and -8 are the same enclosure size. It's just inside, we start with the SI32 PEL64R-4. That gives us 4 poles, so conceivably we can switch 2 strings. Our 6-pole can switch up to 3, and lastly our 8-pole up to 4 strings. These are all 600 volt DC rated with a maximum amperage of 32 amps per string. So when I mentioned that we have the 8-pole that switches 4 strings, that's each string of 2 are going to switch up to 32 amps. And you'll see the dimensions as well of the enclosures. Very, very small, very easy to mount these on a wall. You don't have a giant metal disconnect. It's a nice compact size enclosure. And there's the wiring diagram for each of the 4, 6, and 8-pole disconnects. So very straightforward. 2 wires in, 2 wires out. So let's go over the product overview and features. What makes these disconnects kind of different than others? Well, the main issue with any type of DC disconnection is the speed of switching is always controlled by the operator. That's a lot to do with the knife switch technology and so forth. It's a spring mechanism, and that control can be done by the operator, the speed of switching. A slow switching of contacts will lead to an increased time of electrical arcing between the contacts. Over time, that arcing will just deteriorate the contact surfaces, and it leads to either a failure or fire. It has been known that there are certain AC disconnects that can be used for DC disconnect switching, but they tend to be very oversized. These are the knife blade types, used to compensate for the arcing. So it has to disperse the heat in the arcing, but also too, they also have to consume more jumper poles as well. So the IMO true switching DC isolators, the main features of these, it's a market-leading design. And why I say market-leading design is it is designed strictly around the switching of DC current. It does have a small AC approved current, but we have AC disconnects for that. We have a patented safe lock off feature, which I'll touch into in a bit. That kind of sets us apart from many others. These disconnects are available in a 2, 4, 6, and 8 pole version, as we discovered. And the maximum current rating, we can go up to 85 amps at 600 volts DC or 70 amps at 1000 volts DC. And these are both CUL and UL approved. We have a range of mounting options. We have guaranteed arc suppression, generally under about 3 milliseconds. These are operator independent switching mechanisms. I'll show you the switching mechanism in a sec, why it's very reliable. We still utilize the knife edge contacts. We just augment them a little bit differently than the traditional knife blade types. And our enclosures are an IP65 or a NEMA 4X design. And again, we have these as a CUL approved and UL approved device. And these are also non-fused. So a really quick summary of the different types. As we mentioned in the part number configurator, we have a single hole mount, we have a DIN rail mounted version, as well as a very popular base with extension and door handle mechanism that's common with our customers that are putting together smart combiner boxes. I know some of our inverter companies are using that design a lot. And our panel mount version, which is the PM64R, but most popular for North America is going to be that NEMA 4X PEL64R type. So here's the switching difference. So we've taken apart our disconnect to show you what's different with our disconnect. So as I mentioned before, it's engineered specifically for the effective switching of DC current. So it comprises of 3 main elements. We have the trigger mechanism, the torsion spring, and the internal clutch. So essentially, when the operator rotates the disconnect, it's charging the spring, and at the same time as it's charging the spring, it's the release mechanism will kick a release, what they call a release rib, which will internally engage the clutch, which takes over, and the disconnect will either open or close on its own with that spring. With that being said, there's no worry about operator interface or anything like that. When it switches at its highest speed. This is the interior, what the disconnect looks like. We still utilize the knife edge, but as you can see here, we're disconnecting on the side of the knife. So why that's important is if you can disconnect on the side of the knife blade where there's less surface area, there's less arcing. So you combine the high-speed switching with less surface area for arcing. Also, with that, we have arc extinguishing plates and arc extinguishing ribs. These are meant to drive the arc or starve the arc of oxygen and drive any flaming that's left over out of the disconnect. So what that indicates is we can control the temperature of the disconnect. If we can control the temperature of the disconnect, these disconnects can be manufactured to be smaller. Also, too, we have now as standard the patented safe lock system. So this was actually something that was requested by UL, more specifically UL 508I, which is a disconnect for photovoltaic systems used as an isolation. So what it basically allows is our disconnect handle can be switched on and off as normal, but the locking position is one step further, and it's called the safe lock. What happens is if in the event one of the blades should accidentally, for some reason, weld or fail or what have you, the disconnect, if it was allowed to go to the opposition, if it's welded, it's probably not going to go into the off position. But should it go to the off position, there's no locking provision in the off. You actually have to physically take it to the next position. That safe lock position is a spring position. So if one of the contacts should weld, it's physically impossible to get that switch to go into the safe lock position. You'll actually break the whole, so you'll have to break the whole switch in order to bring it to that safe lock position. And the reason why I want that is if in the event there is a lock or a welded contact, it's better to have the operator not be able to put it in the off position and be able to say, okay, we have some problems here, we have a failure in the disconnect, we need to shut things down and replace, rather than giving it a false sense of being off. So the safe lock is something that we design and something that now is standard with all of our disconnects now. So we'll do a couple of quick comparisons on our disconnects. Common out there, we start with the Square D HU361RB. This is the non-fusible disconnect. It's a 3-pole disconnect. The enclosure type is a metal type. It is a NEMA 3R. Dimensions of it are a standard industrial disconnect, and the electrical rating on it is up to 30 amps at 600 volts DC. Kind of doing a little bit of scanning online to see what prices are out there. We found a US dollar price of $165 from an online distributor, I believe. In comparison, we would offer our SI32 PEL64R-4. This is a 4-pole disconnect. It is a plastic NEMA 4X design, but the size of the enclosure is a lot smaller. So if you can imagine a homeowner that wants to have a small disconnect for their system on their house, they would rather have something very small than versus something very large and kind of bulky. And we have the electrical rating up to 32 amps at 600 volts DC. And typical pricing, US pricing in the States is in around $72, $73 US dollars. And the wiring diagram, well, with the Square D type, they utilize the positive and negative being switched, but you can switch it either 2 ways. You can either switch it through a jumpered system or just straight through the disconnect itself. But in either case, you only have the facility to disconnect 1 string, where in the 4-pole model that we have, we can disconnect up to 2 strings. The Eaton DH161URKN is another non-fusible disconnect. It too is a 3-pole disconnect that's a metal type. It's a 3R design. Similar dimensions of the enclosure to the Square D. It also is rated up to 30 amps at 600 volts DC. And an online list price that we've seen is about $395 US dollars. In comparison to the SI32, again, we offer our 4-pole disconnect, plastic NEMA 4X. Dimensionally, it's a smaller disconnect, smaller footprint. It's rated to 32 amps at 600 volts DC. And again, a US dollar price down in the States is roughly about $72.81. Wiring diagram in the Eaton style, they utilize all 3 poles, and they will jumper poles 1 to 2 and 2 to 3, where in the IMO SI32, we have two strings utilizing 4 poles. And one thing to consider as well too, if you have ground mount systems that have multiple strings, again, we have the 6-pole and 8-pole, which will switch 3 strings as well as 4 strings respectively. With the Eaton Square D, unfortunately, you do not have that facility, and you would have to have multiple disconnects. In summary, these are quality and safe, reliable DC switching devices. Currently, we have over 6 million installations worldwide with no reported failures. They're highly reliable and engineered for longevity, manufactured with high quality materials and workmanship. We calculate the mean time for first failure in and around 87.6 thousand hours and rated for 10,000 mechanical operations. And we also have UL approvals for the line side and load side terminals to accept 2 conductors. So some customers have used it as a sort of a semi-combiner box for 2 circuits. Again, in that solar catalog that we talked about earlier, we do have more information and configurations about these disconnects. That's the DC disconnect side. We can open it up for questions now before we get into the AC one.
Sure, we do have a couple. Somebody's asking if we carry the Fire Raptor. Yes, we can. We're not stocking those currently, but we can definitely bring those in, and we have in the past. So just reach out to your sales rep for pricing on those. We have a question. Does the IMO DC isolator substitute the usual combiner box?
No, because our purpose for the disconnect is for disconnection purposes. However, we have had customers use the open frame disconnects in a combiner box, just to keep one box with one switch, rather than having a combiner box and then having the switch after it and putting a conduit between it or what have you. However, I mentioned in the last slide that we do have UL approval for 2 conductors in each terminal. So you can consider it as a small combiner, I suppose, if you want to combine 2 circuits, 2 positives, 2 negatives, and as long as it is the total amperage, the total VOC, and the total ISC conforms to the disconnect, then there's no problem with that. However, we never brought it out as a combiner box, just mostly as a disconnect.
Thank you. One more. What is your opinion on AC disconnects between inverter and panel in Ontario? Based on electrical code, does this 240 volt disconnect have to be fused or not?
That's a good question, because we've had very, very different paths where people are going. Some of the installations, some of the inspectors really like the old knife blade with the window, the inspection window in it. They want to be able to see that that knife blade is open and closed. Electrically, our disconnects will operate at up to 600 volts. So I mean, disconnect purposes, I mean, it'll suit the application. It's meant to disconnect and isolate the circuit. So we have had our AC disconnects installed in mostly off-grid situations. I don't think I have an example of it right now, but some of the AC disconnects were used to disconnect and isolate the inverter itself. I think it was from utility power, I think.
Then follow up as well. Does code require fuses or not in this configuration?
That I am not sure of. I know in the NEC code, it's not required. I don't know about the CEC code though. Yeah, I'd have to look that up.
Okay, and that's it at the moment. Thank you.
Yeah, no worries. Well, going into our AC disconnects, we have a line called the IMO 69 series AC disconnect. Very similar to our DC disconnects in that we provide on-load disconnection from 10 amps to 125 amps. These are available in a 3, 4, 6, and 8 pole version. We have multiple, like the DC disconnects, we have multiple mounting options available. These are available as a bright yellow enclosure with red handle as seen there, but we do have the optional black and gray combination as well too. In this case, we have up to 3 padlock positions available. Like the DC disconnects, we offer a NEMA 4X design as well. We have accessories, auxiliary contacts, neutral blocks, everything that can just snap onto the side of the disconnect itself. These are suitable for motor disconnection as well, and they're fully CUL approved, and they're a non-fused only. Like the DC disconnects, we offer a variety of different mounting styles, from our panel mount, DIN rail mount, to our base and extension and door handle mount. More commonly here in Canada, we've seen a lot more of the panel mounts as well as the popular enclosed version as well too. And again, those enclosed versions are NEMA 4X as well. A couple of other disconnects that might be of some interest as well. We have one that's a changeover switch. So it's basically 2 disconnects with a mechanical interlock, and now you can switch 2 circuits. So if you have 2 AC services, you wanted to select from, you could easily do that. It does have a center off position. It is lockable, and it's shown there as a just a gray enclosure with red and yellow handle as well too. A lot of customers that use this in selecting AC circuits, they appreciate the fact that there's a lot of space so that they can put stickers to indicate that the circuit is being selected between two sources. The standard PE69 enclosed disconnect, again, we have the yellow with the red handle combination or gray with the black handle. We do have these available in the small style as well as the long version. And you'll see there that we have the smaller disconnects, which are nice. They're very inobtrusive. I mean, that could be put right beside the meter base quite nicely. It's not big and bulky. But if you want a little bit more wiring space, we have the long version as well too. Accessories include a variety of different handle types. We have the pistol grip, the lockable pistol grip type, as well as the common rotary. The common one for us is the rotary handle with 3 locking positions. Extension shafts from 100 to 400 millimeters that can be cut down. Anybody can cut that down and it can be suited for their application. We have auxiliary contact blocks. If you want to signal, let's say the inverter to shut down a designated input, you can have an auxiliary contact that can ground out the switch circuit for that. We have a switching or a solid neutral accessory that also just snaps onto the side of it, and we have terminal covers as well too. Ratings, and I think this graphic might come out a little bit better. As I mentioned, we're up to 600 volts and up to 125 amps. As I mentioned, these are suitable as motor disconnects, so you'll see that we have a horsepower rating as well, up to 15 horsepower. And they're suitable for a variety of different applications outdoors. As I mentioned, these are a NEMA 4X type enclosure. So that being said, that concludes the AC and AC disconnect side as well too. So if there's any further questions, I'd be happy to answer.
Let's see here. If you can use the DC isolator on PV panels, can you use them on battery banks?
Well, it depends on the size. I know that some battery banks demand a UL98 type switch, which is a heavier duty, higher ampacity type switch. Generally, we had these disconnects manufactured originally for PV panels, but we found that the energy storage systems, the smaller types, were a perfect fit for them as well too. The battery systems, though, tend to have higher ampacity, which kind of knocks us out. It goes beyond that 70 amps limit that we have.
And do you have AC disconnects with integrated RSI?
No, just the standard switching disconnect. Yeah, we don't have the RSI.
Okay, folks, are there any last questions here before we wrap things up with Jason? Okay, I'm not seeing any. Oh, I'm not seeing anything. If you have any, please reach out to your rep. Once again, thank you, Jason IMO, for putting the presentation on today. Really appreciate it, and thank you to our customers out there for attending. Just a reminder, information on this product can be found on our web shop, so if you don't have an account already, I would highly encourage you to set one up. The specs, pricing, warranty docs, install manuals, inventory. You can now see inventory by location in our different warehouses. This was recorded. We'll share it on YouTube. So please check out our YouTube channel to be able to see this webinar and others that we do. This will also be shared in the July newsletter. And yeah, if you have any final follow-up questions, please reach out to your reps. We've got a bunch of qualified salespeople waiting to help you out. And thanks again, everybody, and have a great rest of the day.
Yes, thank you very much.